In example 1, we have that someone implied the TRZ level in dogs is 14.85. Researchers want to know if the mean TRZ level in dogs is less than 14.85. 32 dogs have their TRZ levels tested and the mean is 14.46. Assume the population standard deviation is 0.92 and use alpha equal to 10%. So first I'm going to start off by identifying what we were given in this problem, and then we will go through the 5 steps of our hypothesis test. So the first sentence about someone implying that the mean TRZ level in dogs is 14.85, that gives us our population average. So our mu is equal to 14.85. 32 dogs have their TRZ levels tested, so that gives us our sample size of n equal to 32. The mean from that sample was 14.46, so that is our sample mean. That 14.46 comes from that sample of 32 dogs. We are given the population standard deviation of sigma equal to 0.92. And so because we are given sigma, that automatically tells us that we are going to use z-scores because we have the population standard deviation. And we are using a level of significance of 10%. So alpha is equal to 0.10, which implies that C, our level of confidence, which is 1 minus alpha, is equal to 0.90 or 90%. So now we are ready to begin with step 1, which is to write our hypotheses. Our null hypothesis, HO, always gets the equal. So our HO is that mu is equal to 14.85. Our alternative hypothesis, so now we're looking at the second sentence here. Researchers want to know if the mean TRZ level in dogs is less than 14.85. So our alternative hypothesis is that mu is less than 14.85. So that concludes step 1. Now moving on to step 2, where we will calculate our test statistic. Calculating our test statistic, we will be using the formula that z is equal to x bar minus mu divided by sigma divided by the square root of n. So we are using the first formula that we were given, the case 1 formula, since we know the population standard deviation. Plugging into this formula, we have 14.46 minus 14.85. We are subtracting our population average from our sample average, and then we are dividing by 0.92 divided by the square root of 32. You can always round your test statistic to 2 decimal places. And so I'm going to round this off, and this comes out to be a negative 2.4 once it's rounded to 2 decimal places. So now that we know our test statistic, we will move on to step 3, where we determine our critical value and draw our rejection region. So I'm going to sketch a bell curve. Our alpha, our level of significance, is 0.10. And this is a left tail test. And I know this is a left tail test because I look at the alternative hypothesis. And in the HA, the inequality is pointing to the left. So I need to put all of the level of significance of 0.1 on the left. And I am shading that region. That is my rejection region, where I have 0.1 in there. Now we are ready to determine what our critical value is. So we are looking for the z value that has a left area of 0.1 or closest to 0.1. So we are going to head over to our standard normal distribution table, since we are using z-scores, and the closest left area to 0.1 is 0.1003, which gives us a z-score of negative 1.28. So our critical value is negative 1.28. So now that we know what our critical value is, we will drop our test statistic into our rejection region period So we have negative 2.4, and we are dropping that into this picture. And that lands into our rejection region. So step 4 tells us that we will reject the null hypothesis. So we are going to reject HO. And the whole reason that we are doing that is because the test statistic lands in the rejection region. So we have made the decision to reject HO, and so we are accepting HA.
In step 4, we made the decision to reject our null hypothesis, so we are accepting our alternative hypothesis. We need that information in order to write our conclusion for step 5. I always start off with the significance level. We have a 10% significance level in this example that was given to us in the beginning of the problem. So at that significance level, there is enough evidence, since we are accepting the alternative hypothesis, to support the alternative hypothesis, which in this case was that the population mean TRZ level in dogs is less than 14.85.